All right, so July 14th, 2015 is the date that Windows Server 2003 extended support ends. For many people, this is old news, that mainstream support ended quite a few years ago, right, in July of 2010. So this is actually the extended support period that we've been in. What's interesting to note about that is given the amount of time that we've been in extended support and this date coming for quite some, visibly for quite some time, it's actually interesting to see how many people are still running on Windows Server 2003 and have not not only have they not migrated, but they actually haven't even made a plan to perform that migration. So what does that really mean, right? For some customers, it's a pretty significant risk, and we have to deal with the impending date pretty quickly. So what is the real scope of this problem? How big is it? Um, I haven't been able to find specific numbers from Microsoft. I'm sure they probably have very detailed numbers on how many people are actually running Windows Server 2003, but industry analysts estimate that the number is roughly around 12 million servers that are still running Windows Server 2003. There are some estimates that believe that number could be as much as twice that size, but the bulk of the estimates that I found were roughly around 12 million. There were some interesting surveys that have been performed as well. 75% of the organizations that were surveyed have not migrated, and not only that, they do not have a plan to migrate or have a plan in place to migrate. So this is a pretty significant risk for organizations that have been, putting this off for quite some time, and now are, really in some ways out of time to deal with a large number of servers by that end date. Some people are referring to this as a mini Y2K problem for IT organizations to deal with. So what we want to do is provide the clearest path possible and the easiest way possible for organizations to find options, especially with opportunities around cloud, to help resolve the pending issue. So what does it really mean when end of support occurs, right? What does that really mean for customers that are running Windows Server 2003? If you look at 2013, right, in 2013, there was 37 critical updates that were released for 2013. As of the end of life or end of support date, no updates will be developed or released after that date. Additionally, regulatory compliance. For those customers that are in industries that have strict compliance regulation requirements, they will be in an unsupported state and not in compliance, so they need to address that. So they could be, in a position where they may even receive heavy fines. So obviously not something that an organization wants to be exposed to. Uh, Add to that, some application vendors are simply not going to support their application on a platform that itself isn't supported. So there's a combination of things that can happen here, and we want to make sure and address that. So it's not a small issue to just look at. What about custom support? Right, some customers have been working with these scenarios for years. They understand that they can usually write a check, though it may be a very large check and somewhat painful. They can purchase a custom support agreement to manage the transition period that they hadn't responded to so far. Some interesting things to note about purchasing those contracts. The extended support or custom support contracts from Microsoft can only be obtained with proof of a migration plan in place. So it doesn't mean that you can simply have a fat wallet and continue to write checks and just purchase support. You have to show some process and plan about how you're going to move away from the platform and the timeline in which that's going to occur, right? As far as the actual costs go, I won't cite specific numbers. I'll give you, a pretty common number that I've seen. It's roughly, in the order of a couple $100,000 to start for custom support contracts. So, at the low end, still a pretty big number, but you'd have to talk to Microsoft to get specific details on it. So in short, this really isn't a long-term solution, right? You can't just keep writing checks and continue to get the support. You have to do something to move off the platform. So running post end of support, right? Obviously, the first thing to understand is the server itself is not going to just simply stop running at that date, right? And why would we talk about running post end of support for Microsoft? If you look at the number of servers that need to be migrated and the number of, the position that companies are in today, it's just simply not possible for many organizations to perform their migration in the required time that they have between now and July of next year. So they are not going to be able to move in time. So they're obviously going to have some number of servers in many cases that are running for a period of time beyond that. So what's the best way to handle this then? Obviously, the best thing to do is prioritize the applications that you have and focus on which ones you can migrate as they relate to the most important parts of the business. Obviously, emphasis around the greatest risk to the business should be prioritized and moved first. Take a look at the different options that are available to you for doing that, and that's what we're going to be going through here. Highest risk applications first, right? You're going to find that there's really no single plan that's going to work for all the different servers and applications that are running in your environment. And then obviously, once you've prioritized your list, kind of taken a look at the different options and figured out which options are going to work best for each scenario, you want to go ahead and start implementing that plan. So by no means do I think that customers are going to be fully migrated off the platform by the end of next year, but the goal is obviously to mitigate that risk. So what's the best approach? This is really the focus for the remaining part of the lecture and or the webinar, and to discuss different options available to you and see what approach may work best for you. Hopefully exposing you to some options that you may not be aware of and some additional considerations. So in building the plan, obviously discovering which applications and systems are in place. If you're going to prioritize a list, but you don't have the list, you got to surely go out and analyze the servers that are there, assess that list once you have the servers and applications that are running, right? Obviously, looking at business function is a pretty important piece, things that drive sales or support the business, areas around compliance, compliance requirements and risk are obviously going to push certain applications near the top. And then once you rank them in order of priority, you now know the action plan and which ones you need to target first. As far as targeting the new platform, if you're on Windows Server 2003, there's a lot of options, right? As far as moving to Windows Server 2008, moving to Windows Server 2012, and then determining where that server is going to run. Are you going to continue to run it in a data center on-prem, or are you going to move it to a cloud migration? We're going to focus about moving to the cloud and what you can do, but we will still talk through all the other scenarios. So migrating those systems in a priority order is going to help you minimize the risk as best as possible. So as far as migrate, or rather mitigate or migrate, right? Ultimately, you're going to need a plan for both. On the mitigation side, it's really just addressing that some applications are simply not going to be able to be migrated in time or retired in time. So we have to mitigate the risk with those the best way possible. The other applications that we can and we have the ability to migrate, we want to go ahead and perform the migrations that we're capable to minimize the surface area risk that we're exposed to. So the mitigating strategies, right? Again, the fundamental premise is just that every server can't be migrated or addressed by the end of support timeframe. So the mitigating strategy that you want to work with then is, if needed for some number of applications, you may find yourself, in the position where you have to purchase a custom support agreement, right? There's a lot of organizations that are still going to consider that. You're still going to need to put together a plan and make sure that you have the plan for how you're going to move off the platform. So all the work that we're describing and the steps involved there are things that you're going to need to do anyway. So putting together your discovery and assessment phase, getting your ranked priority, and then walking through the list of servers that you will probably need to have support for would be the appropriate order to handle that. Another approach that organizations are looking at is when you have servers that are going to continue running on an unsupported platform, given the security risks and vulnerabilities and the 37 patches that were released last year around those types of concerns. You want to have some way to continue to protect yourself for those servers. So if possible, right, isolating those servers in your data center from other applications so that if they were compromised, they don't have the ability to infect other parts of your organization. Adding additional monitoring considerations and making sure that the applications are being monitored for risk and unexpected behavior is obviously another good option. It's also a good opportunity to look at applications that, if they've been running on Windows Server 2003 for this long, there's probably a good reason. In many cases, customers are running stuff because it just simply works, right? They haven't had a reason to move off it. The application's been fine running on that server, and it's continued to serve the needs well. However, there may be opportunities to consolidate or do some application consolidation and sunset some of these servers and applications. You may even have the ability to consolidate different applications onto a single server. So looking at all the options there as far as trying to mitigate the surface area of how many servers you're exposed to. Obviously, the last option down at the bottom here may seem strange. Leave the servers running and don't do anything, right? Don't take any immediate action. Obviously, that is a strategy, right? And it can be a valid one, but make sure you have a plan, right? The goal being, if something occurs in terms of that server being compromised or failing, how are you going to recover that server? How are you going to stand it back up? How are you going to make the application that was running on it, set up and run again? And maybe your strategy at that point is, if something immediate happens, restore a copy to get it up and running, but then move that one higher in the list as far as trying to migrate. Last, finding replacement applications. Some of the applications that have been running for that long, it may be vendors that you purchased an application from that are no longer available, no longer out there. So looking at other types of applications or other vendors that may be able to meet that need, it's a good opportunity to do that as well. So those are some common mitigating strategies that are available to you. Looking at the migration strategies, right, there's really 5 key strategies that you can look at in terms of getting off the Windows Server 2003 platform and moving to a more modern OS. Right, the first option is to simply do a Windows Server installation upgrade on that existing server and upgrade it. So we'll take a look at what that entails and some of the risks and opportunities there. The other option is to stand up new server hardware and install a new version of the operating system or a more modern version, whether it be Windows Server 2008 or 2012, and then lay the application on top of that, test it, and then go ahead and continue running from there. Option 3 is to move away from the physical data center that you have now and the servers that are running, whether they're virtual or physical, and take advantage of the many cloud opportunities available to you. When we talk about that section, I'll also look at pricing, sizing, scaling, and all the various connectivity, all the various considerations that you need to be aware of and think through as you plan your cloud migration. So there's definitely a few steps to consider in that one. So we'll walk through those in a little bit more detail. There's also quite a bit of opportunities from this virtual world that some of you have been living in for quite a while already, right? A lot of companies have been running virtual applications on virtual servers for some time. So what are the options of moving VMware or Hyper-V or some other virtual platform to the cloud, and what does that look like? If I have a physical server and I want to move that to virtual, what are my opportunities around that scenario? And then, how do I ultimately get off the platform? So we'll talk through those options as well. So the first thing, looking at the base Windows Server installation upgrade, right? In this scenario, what we're simply trying to do is take a Windows Server 2003 box and upgrade it to a more recent version. So some things to think about in that is, if you look at Microsoft's guidelines on supported upgrade paths, one of the interesting steps in supporting the upgrade path is to actually uninstall any applications that are running on the server. Go ahead and then upgrade the OS to the more recent version, say Windows Server 2008, and then reinstall and configure the application on the new upgraded operating system. All right, so this may be a challenge in some scenarios. Obviously, some customers that have been running these applications for a long time may, surprisingly, right, or maybe not so surprisingly, find it hard to find the installation media, the details about that application. So maybe they actually don't have all the required bits or documentation. So it may be harder to perform a clean install, setup, and configuration just simply because of information is missing. Hopefully you're not in that case. but it's not an unknown scenario for customers to be in, right? So that could be a little bit more of a challenge. The other thing is in the scenario of custom applications where the developers that provided those applications are gone, have left the organization, or a vendor is no longer around. Once you perform the upgrade, if you have some compatibility issues, how do you get around those, right? If you don't have any access to support from the vendor, may also be problematic. So this is, somewhat risky in that once I take that server and upgrade it, I don't have an easy step back, right? Obviously, before I do anything here, I'd want to back up that server and make sure that I have some way of restoring to that earlier version should I fail in the end when I go to install and configure my application on the newer version of the OS. You'll also note in this table here that I'm talking about migrating from Windows Server 2003 to Windows Server 2008, and I do not list Windows Server 2012 on the right. There's no direct path from that. Excuse my note here. This should say from 2003 to 2008. I apologize. That's an error in the slide that I just caught. So there's no direct path from 2003 to 2012. So you could do a migration step from 2003 to 2008 and then up to 2012, but you can't skip over. So if you want to just bypass 2008 altogether and go to 2012, you're really looking at a different option. So what about new hardware migrations, right? Another approach would be to leave that existing server that's running Windows Server 2003, procure new hardware, right? And then through that new hardware, go ahead and spin up the new desired version of the operating system that you're looking for, install your application on that new server, apply any of the configuration details that are needed to make that application run correctly. Obviously, then test it, make sure it's working correctly, and then go ahead and switch everyone over to that new server and deprovision the older box. It's a good idea or a good model. The challenge in doing it this way is that obviously the cost of procuring new hardware, and given the amount of time that it takes to go through capital expenditures and those types of things, it may be a little late in your process to start doing that today. So that may be a big hurdle for some organizations. Again, we already talked about the availability of the media and configuration details may be hard to find, but hopefully those are rare scenarios, not the common ones. But I would imagine for most organizations, it's the cost of procuring the hardware in time, given that the support runs out in July of next year. So what about other options, right, or other considerations as we look at hardware? If you think back to Windows Server 2003, the Windows Server 2003 platform really is very different than the 2012 version today in terms of chipsets, right? If you look at Windows 2003 and the hardware, the chip manufacturers in the industry at that time, right? The world was really 32-bit. Intel had come up with their Itanium platform, and AMD was doing their x64-bit architecture, and so was Intel. But the x64-bit platforms were really not readily available, and they were not the common platform back then. So Windows 2003 was really 32-bit support or the Itanium support. And it wasn't until later that we really had the x64 environment. So when you look at hardware today, if you were running on a 64-bit platform then, you were probably running on an Itanium processor, or now you'd be running on one of the x64-bit platforms. If you move up to Windows Server 2008, right, Windows Server 2008 actually supported all the modes. So 32-bit, x64, the Itanium chipset. And then as we move to Windows Server 2012, right, it has support for x64. So the x64 is really natively compatible with 32-bit. So for those of you that might have tried the Itanium versions or had those, you have some other considerations to look at when you look at the version of hardware and which supported platform you're trying to migrate to. Microsoft also published a list of known issues. I'll give you some of the links. There's a lot of information about application-specific things, hardware-specific things that are outside the scope of what we can cover in this talk today. But by no means are they things that you should simply gloss over or skip. All right, so hardware considerations, I would say, is a big one, especially if you're looking at migrating up. As far as app considerations and some tools to be aware of, there's a good, application considerations paper for Windows Server 2008 R2 that gives you a really good list of common issues to be aware of. So take a look at that one in terms of migration. You won't find a very specific or a compatible version of this application considerations when upgrading to Windows Server 2012. So you need to look at the 2008 and then some of the other articles and links that I provide here for other compatibility issues as you look to Server 2012. A bulk of that information is really in this compatibility cookbook, which covers not only Windows Server 2012, but Windows 8 and 8.1. So if you found the application considerations, just know you need to look for the cookbook to get to the 2012 version. Some of the other things that customers are, it's not just the applications that you're running on those boxes, it's the actual roles and features that the server is providing. So taking a good look at the difference of, migrating the different roles and how they behave and new features and roles that were added from 2003 to 2012, right? Obviously, they're very, very different platforms, very different operating systems, and they've had a lot of features added to them over the years. So having a good understanding of how those roles change from one version to the next is going to be important. All right, physical to virtual. This is an interesting one because it actually provides a really nice path to move to a data set, move your data center and move your application up into the cloud and provide a really good option for backup and recovery of that instance if desired. So obviously the key steps are if you have a physical box and want to move to virtual, the virtual platforms or virtual technologies out there will take a look at your existing server. You can point them at it, and it'll build a virtual base image of that server. So depending on which whether you're using VMware or some other platform, you can use their applications to convert it to virtual. Now, in that scenario, what's missing is obviously it's not going to migrate off the existing operating system, right? You're moving it to just from a physical to a virtual, but you'd still be, to Windows Server 2003 to Windows Server 2003. So what does that give you, right? You haven't moved off the platform. What it gives you is the ability to then move that image, let's say, up into the cloud and start running it virtually in the cloud, where you can then provision another instance and start having your applications run in the cloud, get your connectivity and some of the other things we're going to talk about in a minute. Once that thing's running virtually up in the cloud, and you now have different options. If I want to spin up a Windows Server 2008, 2012, right, other instance of the platform, and then move the application to that virtual server, test it. Once everything's running fine, I can just spin down the virtual image of 2003, have a snapshot of it, backups, whatever I want, have extra copies around the different regions or on S3 storage or wherever you want to put them. And now you've got a good backup of your base image as you're trying to do that migration up to the newer version. So it's not a bad way to go. The other things that it can give you is even if you're just moving and you want to have scale options, as we talk about scale, you could still scale that thing up and run it on a smaller instance and reduce some of your costs. So even if you're unable to migrate off it right away, but you simply want to just do some consolidation, you can still do that as well. A lot of companies are creating, repositories of VMs up in the cloud because the storage is very inexpensive and continues to drop in price. So it gives you a good way of creating a repository of images, right, that serve your business needs. So that's also an interesting one. Virtual to virtual is obviously a little bit easier than going from physical to virtual. In this case, you're trying to move the virtual image, right, to a new virtual server farm, or in the case of moving to the cloud, you're trying to export that thing out and import it up into AWS. So there are tools that will help you do that in the case of moving up to AWS. I put some notes in the slides that give you the links, but the import-export API tools that you can run will allow you to point the tool at your virtual image and simply push that thing and convert it up into AWS so that you can export that thing over and then run it in the cloud. So there's tools available to help you do that, whether you're running on VMware or Hyper-V or some of the other platforms. There's pretty broad support for all the different virtual image types. It can take time, right? Obviously, some of these virtual machines are very large, so it may take a significant amount of time to migrate those up. So considerations in terms of the import process are tied pretty directly to your network speed, and that may be a significant hurdle in terms of just bandwidth. What else? So I think I covered most of the cloud options here. Right, once you've got a copy up and running in the cloud, you obviously want to test, just like any other environment that you would validate. We'll talk about some of the other things that you'd need to set up first for that to really work in terms of the VPCs or direct connect in terms of your network infrastructure and how users on your environment connect to AWS in the cloud, either through VPC and a VPN connection or through direct connect. So that also needs to be looked at and thought through so that it's really just an extension of your existing network. So lots of options there. Right. Another interesting way of taking applications and encapsulating them and moving them to a different server and different platform is to leverage some tools that are out there and take an automated approach. So there's one company out there that's pretty interesting in how they're doing this. The company's AppZero. I've listed them there, and I'm not affiliated with them. I don't work for them. I work for another company. But it's a very interesting product in that, what it allows you to do is if you think of, especially the scenarios where you don't have installation media or, you're worried about all the configuration settings that are common in Windows applications, whether it be in the registry or, files on the file system. Lots of configuration information is oftentimes spread in a variety of locations. So how do we package that stuff up and then move it to another server, especially if you don't have installation media? Or even if we do and we don't want to go through all the configuration changes that are going to be needed to make sure that we match those settings, maybe because they're not written down, unfortunately. So what can we do? Well, AppZero really is an application that does kind of the same thing for applications as what virtual software does for VMs. So the idea is to, looking at the middle of this screen, it's really to create this application package, if you will, or this virtual application. And to do that and build this package, it looks at a source machine and discovers the application that's running on it. And it can extract that information and build it into this VAA, right, into this package. That package can then be copied and pushed out to a destination machine and can then be run on the destination machine. Now, what's interesting is once it's running on the other machine, you actually have an option of leaving it in the VAA, in this container that they provide, and running in the virtual application package, if you will. And while it's running, if during the application's operation, let's say there's a request for a file that wasn't caught or captured during the initial extract, you can maintain a connection between the destination machine and the source machine. And what AppZero will do is it'll detect the request for some file that it didn't capture while the application's running, and then it will go through that connection and grab it from the source machine, package it up into the VAA, and then now you have a more complete package. So what's really interesting about the steps is if you deploy in that initial app, or the VAA, I should say, and then test during that cycle, it helps you capture anything that you may have missed should your environment be one where you don't have rich documentation or installation media. So that's a pretty powerful feature and option. Once you've captured those details through your testing cycle, you can go ahead and dissolve the VAA and actually just leave the application installed natively on the server. Additionally, if you wanted to move it to any other platform or any other server, you could easily do that. So if you want to try and run it on, let's say you have a Windows Server 2003 machine today, and you want to verify that you could move it to 2008 and 2012, you could use this tool to extract it and then deploy it on both platforms, test them both out, and then dissolve on whichever one you decide to stick with for your running platform. And this could obviously push to servers that you've procured or up into the cloud, wherever those servers are existing. Doesn't really matter, but a pretty powerful tool. I've listed on the next slide the steps that I just talked through, but kind of gives you the soup to nuts steps required to actually take that application, do all the extractions, package it up, move it across, and then the part I thought was pretty powerful too is while it's running, being able to continue to detect things that may have been missed, and as long as it has that connection to the source machine, it'll grab those files or other configuration information and package it up. So pretty powerful tools there. All right. Now, looking at cloud migration, right? So we've talked about straight up hardware migration. We've talked about buying a new server. We've talked about virtual options, and we took a look at an automated option. Now, if we're wanting to move to AWS and the cloud platform that's available to us, what are some of the things that we need to consider in our planning cycles to make sure that we're successful and actually achieve what we want? Not only just of running, obviously having it running in the cloud is probably the first, version of success, and making sure that the application is running without errors or issues and that users can easily get to it. Clearly, that's an important part. But there's additional things along the way, right? Like there's no reason that we want to miss the opportunity to reduce costs. And how do we do that, right? Obviously, we want to make sure that things are running securely, and we want to understand, what do we have to look at in terms of sizing for the cloud and scaling? What does it mean to be able to scale our application up and down? So I'll take a look in the next few slides. We'll walk through each of these topics and some of the gotchas and things to be prepared for as you plan for migrating to the cloud, and how to handle that. All right. So looking at the security question, it's interesting over the last few years with talking to customers about the cloud, and then moving from enterprise customers, pretty savvy people in the industry, to the standard user, or my mom talking about iCloud on her phone, or my wife. Right? It seems that everybody's aware of the cloud now. And the first initial concern that everyone has when we have data up in the cloud and we see these things on the TV at night, as the news media talks about, hackers attacking various stores and vendors and such, is how secure is this really? So what I always think is pretty interesting is when you look at the security question and you talk through what AWS has been doing and has done to ensure that their platform is secure, and you compare that to the way most organizations are running today. Initially this was I shouldn't say initially, it's always a big consideration, but for many, it's actually no longer the first conversation that we're having anymore. And that is because it isn't brand new. It's been being done for quite some time, and there's lots of information that we can point to about what AWS has done in particular to make sure that the environment is secure, validated by outside agencies, and following all the standard processes that you would expect to be as secure as possible. So if you take a read at some of the quotes, right? Obviously, it's a very critical part of the AWS strategy, and it is a very important piece of everything that they do. So I've posted some links here. I'm not going to go through each one of these links for you, but I will say, if you haven't taken the time to look at what AWS has done in terms of their security infrastructure, their compliance infrastructure, and supporting government version of the cloud and those types of things, take a look at what they've done and all the certifications that they have, and then think to your own data center and your colo facility, and does it even come close to comparing to what's been done on the AWS platform? I've found in most scenarios, what AWS is doing is far more extensive than what many customers are able to or willing to afford. So for many of the conversations, it's not that it's no longer a question, it's just that the answers of how it's dealt with and how mature it is are already there. So take a good look at these. Take a read, and I think most of you will find that they're probably doing a lot more than you're doing in your own environments in terms of security. So that's an important one to dispel at the onset, especially with any execs or anyone that may be concerned. Compare it to how you're handling things in your data center, and see where you fall in that scenario. The next big one is when you look at on-prem environments and you look at somebody trying to move to the cloud, the easiest way or the most common way that customers first start thinking about it is, I have a server that is handling a certain type of capacity or a certain capacity, and it was sized based on handling, a maximum capacity or maximum utilization needed for my organization. And if I just take that and airlift it and try and get a server that's the same size in the cloud based on the way we sized and dealt with capacity planning for on-prem, we're really missing an opportunity to leverage the cloud the way it's meant to be leveraged, which is that of a utility model. So if you're thinking about typical house, right? I've got electricity coming in off the grid. I don't have to pay for the amount of electricity that could come through the grid. I just pay for what I use. And obviously in the day when everybody's awake and air conditioners are going, dishwashing machines and such are on, I'm going to consume more. And at night, I should be consuming less. So if we take our server story and we take the on-prem model and we simply package it up and allocate a server that's the same configuration up in the cloud, but we don't consider how we use or how that server is utilized by our business, we may find that the office only utilizes the servers for about 10 hours a day. 2 out of those 24 hours in a day are where we have the max utilization. So that's maybe what the server was really sized for, is this peak utilization. And then 14 hours a day we have a lot of idle time, but it's still running. So if I provision a really big box in the cloud and I'm not using it for 14 hours a day, or it's pretty idle, then I'm paying for a lot of excess capacity that I really shouldn't be paying for. So we need to figure out how to take advantage of this through a different model, right? By looking at provisioning smaller instances of a server and maybe spinning up multiple small instances as demand increases, and then bringing that down. So the first thing to change the way you think in terms of how you size the servers that you're going to run on in the cloud is a very important part of making sure that you're not overpaying for what you need. So the key goal here is you don't want to pay for time, right? Why not just spin those things down or turn them off? So this really leads to the next topic, which is around scaling, right? How do I scale those applications so that I can, not only run effectively from a cost perspective, but as demand increases, I can meet that demand immediately, scale up the number of servers that are required, and then even more importantly, as that demand drops, I can scale those servers down. So there's opportunities here that instead of just sizing in the old-fashioned on-prem model, getting a certain number of servers to support the peak loads, I want to have smaller instances and then scale up maybe multiple instances. And then the other thing is to look at how there's a lot of different instance types in AWS that are optimized around the way your application is running and what it actually needs. Some applications are more memory intensive. Other applications are more CPU intensive. Other applications have a lot of IOPS or requests to them, so input-output operations. And I can pick various instance types and around the optimization for my application. So if it's CPU that I need, I can buy an instance type that's scoped around more CPU to provide me that optimization. The key here is that we want to take advantage of this ability to spin up and down, as opposed to having one big instance or a couple big instances that are running all the time. Now, this is easy to say, and it's actually not hard to do in some scenarios, but obviously creating a scaling model may require some significant configuration or alterations to your applications, right? So not all applications are going to fit into this model easily. So obviously that is a factor that I'm sure you guys are aware of as I am, but you want to make sure and look at this as part of your planning and sizing infrastructure in order to achieve the most benefit from moving to the cloud. The other one is resource usage and cost. I find this amazing to me that Amazon will actually not only help you get to their platform, but once you're there, they'll work with you to reduce your cost, right? It's like, what vendor in the world am I used to buying something from or buying a service from that as soon as I buy off on the platform and invest, they're then going to help me reduce my bill, right? It almost seems counter to the whole goal of getting you on the platform. But amazingly, they provide a significant amount of tools and opportunities to help you get onto their platform, as well as once you're on it, continue to optimize around the things I'm talking about in terms of choosing the right instances, um, sizing those correctly. As far as the three instance types that are available, you can have an on-demand instance, which you're going to pay more for. So if I would just want to spin something up on demand, obviously, for that to be available, and I haven't reserved it for some period of time instead, I'm going to pay a little bit more upfront on. If you know it's something that you're going to have running all the time, you might find that it's better to have a certain small number of instances that are reserved instances, and those costs drop dramatically. So if I reserve the instance for X amount of months, I'm going to pay a much reduced price for those instances, and then maybe as demand peaks for that 2 hours a day, maybe I have on-demand instances that scale up and then drop off, and I just consume the on-demand price for those scenarios. For some people that are doing more interesting high intensity calculations and stuff and don't really care when these things run, they just want to get some number of servers to do a bunch of calculations and run some models against and then shut them down. You also have things like spot pricing, where you can take advantage of excess capacity that's available in the platform and in essence bid on a price and say, here's what I'm willing to pay, and get access to excess capacity, run your application and your calculations that are needed, and then let go of those spot pricing instances. So pretty sophisticated model available to you. Up above, I did mention the calculators. So there's a monthly calculator that you can walk through and enter in a lot of different things. So if you're looking at S3 storage, disk storage or Glacier storage, or EC2 instances and the different types, there's calculators that will help you figure out what it's going to cost all up for my platform to do that. Another one that's interesting, just in terms of third-party tools that some people may be aware of, some may not. There's a company called Cloudimize. There's others out there. This is one I happen to be familiar with. But this is a pretty interesting tool in that you can take your existing Windows Server 2003 application or instance that's running, and you can actually have this tool look at that instance and look at how it's utilized. So Cloudimize will basically monitor that application as it's running and its utilization, and then it will give you back a report that provides a recommendation for what type of AWS instances and disk storage and IOPS that you need to support that application in order to optimize around cost. Now, obviously, for industries that may be cyclical or seasonal, if I'm monitoring in June and the peak is Christmas season, I may be missing the important part, so I may get sizing information that's flawed. So obviously, the longer that utility can run, the better information it can give you around sizing and pricing. Pretty standard is about 30 days. What's also interesting is once it's running, once you've done that tool, use that tool and had it help you figure out initial sizing information and move to the cloud and have those servers now running in AWS infrastructure, you can actually continue running the tool to continue to try and optimize your costs in the environment. So, lots of opportunity to reduce costs and make sure that you're not paying for more than what you're really consuming. So make sure you consider those things. Now, another important piece, obviously, besides the ones we already talked about, is connectivity, right? How are my users in my building, in my enterprise, through all the different buildings throughout my organization, how are they going to connect to this stuff that we have up in the cloud? So really, there's two main models. There's the AWS Virtual Private Cloud, which is your virtual network that you define, and you can specify all the rules around private subnets, which servers have the ability to call out to the internet, which servers are on have a public IP address that's accessible. subnetworks between application layers if you want. So from your database layer to your application layer to your web layer, what ports and protocols can communicate through those different subnets. So there's a lot of configuration and planning that can be overlaid on top of this and should be to make sure that it's adding additional layers of security and that only the traffic that you expect is flowing within the VPC and across the different networks or subnets. And so that's one piece. For that VPC, as it gets set up and configured in the cloud, you can then set up a VPN connection from your data center or your office, right, wherever your users come through. And you can have a VPN connection that uses the virtual private gateway. So you have a gateway on both sides and a VPN connection that's always available so that your users can, in essence, see the AWS VPC and any servers that are running in that VPC is just an extension of your existing network. So that's one way to do it. So through VPC and think of traditional VPN, right, as your primary mode. You could have it set up so that the VPC is running and users just need to connect to that VPC through an RDP session and not have a dedicated VPN setup for developers. That's also possible. For real applications exposed to the users, you're probably going to have a more persistent type connection like a VPN that's always available. The other option that's pretty powerful is AWS Direct Connect. In this scenario, what it gives you is the ability to have a dedicated network connection from your on-prem environment to an AWS data center. So this is obviously something that is a little bit more timely in terms of getting set up and provision. It does take a little bit more time, but not a significant amount of time than the top option on the VPC. But what it does is it gives you the ability to reduce costs, right? Have greater bandwidth and performance. So the direct connect is also a really good option. So make sure, if you're looking at your long-term strategy, you probably want to consider a direct connect option. If you're just trying to get things up and running and started, you'll probably look at a VPC path. So those are two things to make sure you have sorted out in your plan. And then once you have that set up, right, and you've gone through sizing and all the different pieces, the next part is really what is needed to perform my application migration, right? It's really as easy as, in many cases, just getting an account and connecting to AWS and choosing to start an instance and pick the type and it's up and running. Right? I've added a few more steps here to be more complete with running in the real world, not just trying to spin something up for demo purposes or developer purposes, let's say. But the short list is really I need some way to have my users connect to that infrastructure, right? So I'm going to have to configure the VPC and the network settings. I'm then going to need some instance that's running up in the AWS platform. So I can select from an existing set of AMIs and choose what version of Windows Server or Linux, right, or whatever platform. AWS has a variety of platforms. I've just listed the Windows platform since this was focused around the Windows Server 2003 migrations. So along that theme, if I'm looking at Windows Server 2003 and moving to 2008 or 2012, those are types that I can just select. So I choose the region that I want to run those things in and go ahead and spin up that instance by selecting then the instance type. So the instance type gives me that information about how much memory, how much CPU, what's the size of this instance, how much data storage, IOPS, those types of things, and then start your instance, right? Once that's done, you now have an instance that's up and running that you should be able to easily connect to. And then you're going to install your application onto that instance, test it, and release, right? So not too difficult to get up and running. The pre-planning work, right? I'll say from a cost savings perspective and sizing, you definitely want to think about those things we talked about on the prior slides to make sure that you get the pricing information right and don't just spin something up and leave it running and pay excess when you don't need to. So very very straightforward. I'm sure a lot of you guys have already done this multiple times, and that's it, right? So what we took a look at here is key considerations around end of support from Microsoft. End of support is ending on July 14th, 2015. So if you haven't started and you got a lot of servers, you're late to the prom. You definitely need to step it up and come up with a plan and reduce your risk. looked at different support options that are available for those of you that are going to continue running on Windows Server 2003 post end of support. It's not to say that there's no options, just they have a little bit of risk or some cost associated with them. We walked through mitigating and migration strategies, to help plan and try and reduce surface area of exposure for compliance and risk, and then looked at the various strategies in detail for how you would migrate hardware configurations, security, all the various pieces. So that's it.